in your book, page 127, properties of parallel lines. Okay, and so you have different. On the first page, you can see transversal is a line that intersects two coplanar lines at two distinct points. The diagram shows the 8 angles formed by a transversal. Okay, so you can see if we, whoops. If you're looking at a transversal here, all right, you have exterior are the angles that are outside of the two lines. Interior are inside of the two lines. Again, exterior means they are outside of the two lines. Interior means that they're inside of the two lines. If you look at the screen share, okay, this should be very clear by this image right here. If it's not clear, let me just go ahead and bring some more clarity to it, okay? Let's go with we'll just go with black. All right, so outside here, you are dealing with exterior angles because they are outside of these two little lines. In here, okay, these are the interior angles, okay? Very, very important to understand the difference between interior versus exterior. It is not complicated, but if you do not memorize it right now and look at it and understand, okay, you will get all of these wrong. It is not too difficult for any of you. However, if you're not paying attention, you will miss it, and what is simple will become hard. Okay? Now, let's move on to the next page. Here we have, let me move these. Here we have a few other different ways that we determine angles of lines. Alternate interior angles, you can see by the drawing here, 4 and 6, they're alternating interior, and 3 and 5 are also alternating interior. Okay? If we move down to the bottom down here, alternating exterior, see 7 and 1, 2 and 8. They're alternating, meaning they're not on the same side. See, 1 and 8 are not on 1 and 8 are on the same side, so they would be corresponding. Okay, whereas 2 and 7 are also not on the same side. They are on the same side. So when we say alternate, we mean opposite side, like 8 and 2. They're alternate, they're on alternate sides of the transversal, and they are exterior, okay? Also, you could have alternate interior, which would be like 4 and 6, 5 and 3, right? You see that right here, alternate interior, okay? So it's very important to understand what alternate means, interior versus exterior. So far, our vocabulary, interior, exterior, alternate, okay, when we're talking about angles. And now we're going to talk about same side interior angles. This should be automatically understood. They're on the same side of the transversal and they are interior. Same side as the transversal and they are interior. Now we haven't mentioned anything about these angles. We are just learning how to label the angles. Because when I talk, I'm going to say, if you notice, these are alternate exterior angles. You must know what that means. Okay? Alternate interior angles. You must know what that means. Same side interior angles. Corresponding angles. Okay? What is corresponding angles? They are the same side of the transversal and in corresponding positions. What do we mean by corresponding positions? We mean here 2 and 6, they're not both exterior, they're not both interior, however, they are corresponding. They're on the same side of the transversal and they correspond to the same position, meaning just above one line to the right, right? If these are 4, 6 would be top right. If these are 4 angles, 2 would be top right. So they are in the corresponding or the same position as each other, okay? That being said, Luigi, give me 2 angles in this that are corresponding, other than the ones that they gave you. Other than 2 and 6. So not 2 and 6. Give me another set of corresponding angles. It's pretty simple. It's right there.
1 and 5? On the same example, right? 1 and 5?
Exactly. 1 and 5. All right, George, give me another example. Not 2 and 6, okay? And not 1 and 5. What's another example of corresponding angles?
4 and 8.
Good. 4 and 8. Okay? Very good. And then the last would be 3 and 7. Okay? So hopefully that's pretty crystal clear for you guys, those different angles. If it's not crystal clear, this is something that you guys can study. This is in your book. This is also in the digital book that I have. Okay? So when we talk about which is a pair of alternate interior angles. So alternate interior angles, 2 and 6. There's no, here we go. C is 2 and 6. Right. 7 and 3. There's no option for 7 and 3. 2 and 6, 7 and 3. Those are the only 2 interior angles, alternate interior angles. So 2 and 6, C would be the answer. Okay? Because they lie on opposite sides of the transversal and they are in between the 2 lines. Okay? So let's continue moving forward. All right? I'm going to now jump from here into our Jamboard and write a little bit of this down so that we can then remember it. Okay? So first of all, we have interior, exterior, alternate, same side, and corresponding. Okay? So interior would be between the 2 lines. Would be outside. Exterior would be outside the 2 lines. Alternate would be on opposite sides of the transversal. Okay, you should know also. Okay, same side is the same side of the transversal. Corresponding angles are in the same relative location as each other. And the transversal intersects 2 lines. It's a line that intersects 2 lines. All right, so let's just go through these quick examples. Right, there's 4 alternate interior angles. That is how Mr. Scribner draws it, right? So if we've got 2 lines, a transversal, A and B. Okay? Alternate interior angles. Okay? Let's try alternate exterior. There's Mr. Scribner's shorthand terminology. Alternate exterior angles. Alt-ext angles. Okay? Continuing on. What else do we have? Same side interior. Same side interior angles. Okay? Again, not complicated. It's just knowing what they're called. Corresponding angles. Corresponding angles. Again, my shorthand, you need to get used to it. Again, here we are. We've got alternate interior, alternate exterior, same side interior, corresponding angles. Okay? Now, here is where the very crucial part to memorize and to learn comes in terms of geometry. Now we are moving on to page 128 to where we have a postulate. Okay? So let's look. Alright, where's our postulate? Let's find our postulate. Alright, postulate 3-1. Okay? Same side, interior angles postulate. Okay? This would be alternate. Okay, wait, hold on. All right, in your book, this is a little bit different, so don't necessarily like that. The postulate 3-1 in your book says corresponding angles postulate, and here it says same side interior angles postulate. All right, now I want you guys to understand something. Take note. Pay very close attention. When I want you to write the reasoning when you're doing your geometric proofs, I want you to write it like this: corresponding angles. I want you to write it as same side interior angles. Okay? I don't want you to necessarily say theorem 3-2. Okay? Because theorem 3-2 tells me that you went and looked in your book and found theorem 3-2. You don't actually know that theorem 3-2 is the same side interior angles theorem. Okay? Now, what do I mean by that? Ultimately, there are three that we have here. Okay? You have the corresponding angles postulate. You have alternate interior angles postulate. Sorry, theorem. Not that it matters. And you have the same side interior angles theorem. Okay? So these three are very important. What do they say? Well, if you're dealing with the parallel lines, if a transversal intersects two parallel lines, then the corresponding angles are congruent. Okay? So here we are, the corresponding angles postulate. All right? If you have two parallel lines, you see a little arrow like this. This means parallel to this. Okay? So either you need a given, like they need to tell you that they're parallel, or you need to see this symbol. Okay? So if we're answering a question, and I say, Luigi, how did you know that those two lines are parallel? And you say, because of those little single arrows. Okay? Those little arrows. Now, here is our transversal. So the corresponding angle postulate says if we went 1, 2, 3, 4, 5, 6, 7, 8, we could say 2 is congruent to 6. And the reasoning We call this a statement. And a reason is corresponding angles postulate. Okay? Very important that 2 and 6, they are congruent angles. Now, the next one is based on the same premises that we went over in terms of our alternating interior and same side angles. Alternating interior theorem, all right, says if you have two parallel lines and a transversal, right? Now watch how this works. I'm going to show you the logic, and then I'm just going to give you the proof or the definition. Okay? Here's the logic. If 2 is congruent to 6 because of the corresponding angles, right? We just said 2 is congruent to 6, right? Because of corresponding angles postulate. All right? Now, if 2 is congruent to 6, and we know that 2 is congruent to 3, right? We can say 2 congruent angle 2 is congruent to angle 6, right? Because of corresponding angles. All right? Then we can say 2 is congruent to 3. Why? Because of vertical angles, right? 2 and 3 are vertical angles. Then we can say 6 is congruent to 3 because of, my gosh, I'm blanking on the law, on the transitive. Transitive of congruence. The transitive property of congruence, right? If 2 is congruent to 6, 2 is congruent to 3, then you can say 6 and 3 are congruent, right? Because we know that 2 is congruent to 2. If we were doing a proof, you would probably start off by saying 2 is congruent to 2 by the reflexive property of congruence. 2 is congruent to 6, 3 is congruent to 2, therefore 6 is congruent to 3 by the transitive property of congruence. Okay? So then we can say these two, right? If 2 is congruent to 6, 2 is congruent to 3, then you can say 6 and 3 are congruent. All right? That right there is the proof proving this theorem. So now, no longer do you have to do all those steps. Forget about those steps. You can simply cross all of this out, and you can simply just say angle 3 is congruent to angle 6. You don't need any of those steps. This is your statement, and somebody proved it, so now all the reasoning you need is because of the alternate interior angle theorem. That's all you need. You can get rid of all of that because somebody already did that proof and created a theorem from that proof. So this is all you need. Okay? Any questions about that? All right, one last one that we're going to learn about today, and that is the same side. Sorry, no, it's not the last one. Gotcha. The next one is the same side interior angles theorem. Okay, how would that work? Well, if you have 1, 2, 3, 4, 5, 6, 7, 8, same side interior angles. So 4 and 6. They are not congruent, but we know that if 2 is congruent to 6, right? And we know that angle 2 plus the measure of angle 4 equals 180. Why? Because of the definition of supplementary angles. Okay? 2 is congruent to 6. Why is 2 congruent to 6? 2 is congruent to 6 because of corresponding angles. Right? Because they're corresponding. So we can say if 2 is congruent to 6 and 2 plus 4 equals 180, then we can say measure of angle 4 plus the measure of angle 6 equals 180 by substitution. Right? We're simply taking the measure, we're taking 6 and we are substituting it in for angle 2 on this equation right here. Because we said 2 is congruent to 6, so we can then replace the 2 with the 6 to get this. Now, to make it a little more clear, I could keep it in the same order, right? I could say the measure of angle 6, right, because I just replaced those, plus the measure of angle 4 equals 180. Okay? So hopefully you guys can see that. I literally just substituted those 2 in because we know that 2 is congruent to 6 because of corresponding angles. I can substitute 6 in for the 2, and now I've got 6 plus 4 equals 180. Now, I have to know that these 2 equal 180. Why do I have to know that? Because anytime you have a line, all of the angles to make up that line equal 180. Okay, and that's the definition of supplementary angles. All right, so continuing on, we're moving to the next page. Alternate exterior angles theorem. Okay, so alternate exterior angles theorem. All right, let's move on to the next page. What does this say? Well, it's very similar to the alternate interior. We got 2 parallel lines. 1, 2, 3, 4, 5, 6, 7, 8. Alternate exterior angles would be like 2 and 7, or 1 and 8. Okay? Alternate meaning opposite sides of the transversal. Exterior meaning outside of the 2 parallel lines. Angles theorem. All right? So, what can we say here? Well, we can say if 1 is congruent to 5, right? And 5 is congruent to 8, then we can say 1 and 8 are congruent to each other. So let's go ahead and prove the alternate exterior angles theorem, and then we're going to get rid of the proof because somebody created it. But I want you guys to see how we prove this, how we get there. Well, we can say angle 1 is congruent to angle 4. All right, let's see if you guys can remember this. Nazari, why is angle 1 congruent to angle 4?
Because they are vertical.
Vertical angles. Excellent. Vertical angles. All right? Rob, why is angle 4 congruent to angle 8?
Because of corresponding.
Good. Corresponding angles. Right? They're in the same position. They're both bottom right. Okay? So we have vertical angles, corresponding angles. So therefore then, I basically just said 1 to 2, 2 to 3. So now I can say 1 to 3, if you will. I can say angle 1 is congruent to angle 8. Why, Heidi? What's the reasoning? Okay, well look, so alternate exterior is what we're trying to prove. Okay? But look at this theorem right here. We have corresponding angles, vertical angles. So we said one was congruent to one was congruent to another, and then we said 6 and 3 are congruent to each other, right? That's our final answer, 6 and 3. But why? Why are 6 and 3? How can we can say that? If you prove one is congruent to one, and then that other one is congruent to a different one, then you can say the first is congruent to the last, right? 1 is congruent to 8. And what is the reasoning? Heidi? All right, Luigi, what's the reasoning?
Well, they're not vertical.
Here we are right here, Luigi. Alternate exterior angles theorem, we did this earlier, right? We said they were corresponding angles, we said they were vertical angles, and then why can we say that they're then congruent?
Well, they need to be equal, but they don't seem vertical.
All right, Rob, why are they congruent?
Because of the transitive property of equality.
Sorry, transitive property of congruence. Of congruency, yes. So listen, anytime you have this logical thinking, Luigi and Heidi, do not forget this. Anytime you have this process, 1 to 2, 2 to 3, then 1 to 3, right? 1 goes to 2, 2 goes to 3, and then you just say, we can skip 2 now and go straight to 3, okay? It also works like this. If 2 to 1 and 2 to 3, then you can say 1 to 3. It works any way like that. Anytime you say two separate groups are equal, you can equate anything in those groups by the transitive property, okay? It's kind of like if A equals B and B equals C, then A equals C. That's the transitive property of equality. This is the transitive property of congruency, okay? You cannot forget this. This was last chapter. You needed to memorize it last chapter. If you didn't, go back to the properties of equality, the distribution property, the properties of congruence. Memorize them, what they look like. Here, on this problem, we have 1 to 4, 4 to 8. So how can we say that 1 to 8? Because of the transitive property. Okay? Cannot forget that. So that is the proof. Now, you will need to understand that logic. That logic must stay with you. However, for alternate exterior angles, no longer do you have to do all those steps. You can simply just say 1 is congruent to 8 because of the alternate exterior angles theorem. That's what you can write on your proofs. Okay? That's all you need is the alternate exterior angles theorem. All right, let's continue on. Now we have the same side exterior angles theorem, which is basically the same as the same side interior angles theorem. Same side exterior angles theorem. All right, what does this say? This one, 1, 2, 3, 4, 5, 6, 7, 8. All right, so same side exterior angles. So we're dealing with 2 and 8. Okay, so what we can say is if angle 2, the measure of angle 2 plus the measure of angle 4 equals 180, right? Those two. Because they make a line. What is the reasoning of that? The reasoning would be that they are supplementary angles. Definition of supplementary angles. Okay. Then we can say angle 4 equals angle 8, or is congruent to angle 8. How can we do that? Because of corresponding angles. They're both in the bottom right of the two sets. Okay? So we can say 4 is congruent to 8. Then we can substitute angle 8 in for angle 4 in this question, and we can say the measure of angle 2 plus the measure of angle 8 is equal to 180. I literally just gave you the answer, so if you're paying attention, this should be a slam dunk. Naomi, I don't know if you can use your mic. Why can we say that this angle 2 and angle 8 equal 180? What is the reasoning? Okay, maybe Naomi can't respond. Luigi, what is the reasoning?
Right? Okay. They're congruent. That's why.
Okay, follow my process right here. Angle 2 plus angle 4 equals 180.
Yeah.
What did I do to this equation right here? To get to this equation, what did I do? What do you call that?
You multiplied 4 by 2?
No,
It says 8 now.
no. 8 is the name of the angle. It is not a number. It is just a name. It could be A, it could be B, it could be whatever. It's an angle name. It is not an angle amount. It is not a number. The question is, we took the measure of this angle plus this angle to equal 180. So instead, I'm going to swap the 8 and the 4 out for each other because 8 and 4 are equal to each other. What do you call that process of swapping them out? What is that called?
Substitution.
Substitution. All right, you guys got to follow me and stay with me. I literally said I'm going to substitute the 8 for the 4. Okay? I said that. I'm substituting the 8 for the 4 into, and that's where you see it down here. I substituted the 8 in for the 4 up there. Okay? Now, if you were watching earlier, when I did this one, we did the same thing. We said 2 is congruent to 6, 2 plus 4 is 180, so I'm going to substitute the 6 in for the 2 because they're corresponding angles, and that's substitution. Okay? Do not forget that. All right. Now, that is the last one of section 3.1. Now, if you jump to section 3.2, okay, you have the converse of corresponding angles, the converse of alternate interior angles, and the converse of same side angles, the converse of ulterior exterior angles, alternate exterior angles, and the converse of same side exterior angles. Okay, so basically the converse of each of those theorems. Okay, so let's look at it. Here we have the converse of alternate interior angles, the converse of same side interior angles, and the converse of alternate interior angles. Sorry, alternate exterior angles. Okay. I'm gonna copy these and put them into our Jamboard. This way you guys have them. Should be one more. No. Okay. Well, it looks like this. We're missing one here. Copy the corresponding. Interior. Same side, interior. Same side, exterior. So the only one is the converse of ulterior. No. Alternate exterior. So the only one that we don't have is converse of same side exterior angles. Okay, which is fine. Let's go ahead and insert this into our Jamboard. Bear with me for 1 second. All right, now let's jump back into it. All right, so here we go. All right, so you guys have the same thing in your book on page 134, okay, and 135. And so what it's saying is, if two lines and a transversal form alternate interior angles that are congruent, then the two lines are parallel, okay? Guys, this is all very, very simple, okay? But if you're not paying attention, you're going to miss it. It's going to go over your head. Listen to the simplicity of this. We just did a bunch of different theorems about how when two lines are parallel, you have things like, we just proved that 3 and 6, right? We just proved things like this, right? So, if you can prove that, we're going to call this line A and line B. If you can prove that 3 is congruent to 6, then A is parallel to B. That right there is the logic of all of these. We just proved that if the lines are parallel, then the angles are congruent. So therefore, if the angles are congruent of this scenario, then A and B are parallel. So we're simply doing the converse. Okay? Remember, last chapter was conditional statements. If A and B are parallel, then alternate interior angles are congruent, 3 and 6. The converse is, if alternate interior angles are congruent, then A and B are parallel. Now, in this case, they use L and M. So L is parallel to M. This means is parallel. So look at theorem 3.6. If two lines in a transversal form the same side interior angles that are supplementary, meaning if the measure of angle 3 plus the measure of angle 6 equals 180, then angle L is parallel to angle M. If 3 plus 6, angle of 3 plus 6 equals 180, then you have parallel lines. Okay? The same thing for 3.7, alternate exterior angles. If, right, you have it here, if 1 is congruent to 7, then L is parallel to M. All of them are the exact same, they are just the converses of. So, when would you use the converse? You would use the converse if you're trying to prove that they're parallel. You would use the actual theorem, right? Alternate interior angles theorem, corresponding angles theorem, alternate exterior angles theorem, right? Corresponding angles theorem. What is it? The same side interior angles postulate, same side exterior angles postulate. You would use all those to prove the lines are parallel. Okay? You would use all those to prove the angles are congruent. You use the converse of each of those to prove that the lines are parallel. All right, let's jump to the next Jamboard page, and you'll see the next one. Okay? Same concept here. If angle 2 is congruent to angle 6, we don't know that these are parallel lines. We do not know that. But you can prove that they are because these are corresponding angles. Okay? So how would you write this in your proof? If I was giving you a proof, you would say your statement, right? It might have been given to you, right? But you might have been given like angle 2 is congruent to angle 6. Right? Maybe that was given to you. Or maybe you were able to prove it. Then you could say L is parallel to M, and the reason why is converse of corresponding angles. Okay? Converse of corresponding angles. Why? Because whenever you're trying to prove that they're parallel, when you want this, it's always going to be the converse. Okay? Very important to know the difference between the theorem and the converse. Okay? Very important. So, before we move on to some questions, right? Any questions about what we just talked about? All right? The last one that we haven't gone over because it's not in the digital book is the converse of same side exterior angles theorem. Right? That basically just says if you have 1, 2, 3, 4, 5, 6, 7, 8, if angle 1 is congruent to angle 7, then A is parallel to B. Now generally when you write it, as you noticed, right, you would have kind of like cursive letters to help you differentiate between angles and lines, right? You must know that this right here means parallel. Okay? All right. Let's go ahead and attack 3 questions from each section. Okay? 3 questions from each section. Then I'm going to assign you guys quizzes. I will give you the teacher pages for all of the sections, for both of these sections. I will upload them today. So you can practice the questions in your book, see the teacher pages, see if you got it right or wrong. Once you get enough of them right, then go ahead and jump into the quizzes assignment. If you get a bunch of them wrong, go back and practice some more. All right, here we are. We are, actually, we're going to do it in, because you have the teacher book and the teacher pages for your book. We're going to do it in this digital book because these are questions that you don't have or don't have answers to. Okay? So here we go. Number 10. Let's go ahead and do that. Let's also all right, let's attack some of these. Whoops.
Mr. Scrivener, what screenshotting software do you use?
No software. It's just Command Shift 4 on my Mac.
I see. Oh, okay, so then I don't use a Mac, so no.
Command Shift 3 on a Mac allows you to screenshot the whole screen. Command Shift 4 allows you to screenshot a particular region. So, all right, let's jump back into our full screen. All right, so here's our proof. All right, I don't want to make it too big because I want to be able to write. All right, I'm going to try and get you guys out of here, so pay attention. We've already gone over all this. I'm going to be moving relatively quickly in that regard. Okay, so just, you can always come back and watch the video as we, that I upload after. Okay, so here we have, we're trying to find the missing reasons, okay? So as I teach you guys, we're going to do little baby steps first, right? We just did the theorems. Now you're going to be doing pieces of the reasoning. Eventually, you're going to have to do your own proofs, the whole thing, okay? So, angle A is parallel to angle B. That's given to us, okay? That's given to us, which means, right, that we're probably going to use the regular theorems. We're not trying to prove that they're parallel, all right? Angle 3 and angle 2 are supplementary, okay? So basically, 2 plus 3 equals 180, right? Angle 2 plus angle 3. Angle 2 plus angle 3 equals 180, all right? What can we say that proves that angle 2 and angle 3 is 180? The answer would be same side interior same side interior angles. I don't know when my pen is tripping out. Okay? C is parallel to D given 1 and 2 are supplementary. Right? So it means 1 plus 2 equals 180. Okay? How would we know that? Because of same side interior angles. Right? 1 and 2, 2 and 3. Same side interior angles. So therefore, angle 1 is congruent to angle 3, right? Understand, we have 3 plus 2 equals 180. We have 1 plus 2 equals 180. All right, Luigi, a chance to redeem yourself. Right? If we said this plus this equals 180, and this plus this equals 180, 2 is equal to 2, so therefore 3 is equal to 3, okay? I'll actually accept 2 answers here. What is the reasoning for 1 is congruent to 3?
I'm thinking about the different properties. I'm not sure if it would be transitive. like
Okay.
last time.
So you could say transitive.
Okay.
You could say the transitive property would work, okay?
What about substitution?
Now, substitution, technically, I wouldn't be upset if you said substitution, okay? However, we're not substituting something into angle 1 or 3, okay? We are saying that 3 and 2 are supplementary, 1 and 2 are supplementary, so therefore we can then say 1 and 3 are congruent and by the transitive of congruency. All right, very good. Continuing on, I'm not going to do all these, I'm just going to do one. Find the measure of angle 1 and the measure angle of 2. All right, so we're going to do this one right here. Watch how simple this is and how fast this is. Measure of angle 2 plus 75 degrees equals 180. The measure of angle 2 equals 105. What is the reason? 2 and 75? What the reason is? Supplementary angles. They are supplementary angles because they make a line. Okay? So the measure of angle 2 is 105. Alright? That would be the subtraction property of equality. Okay? Now, if we have to do a separate one, right? To find the measure of angle 1, we can say the measure of angle 1 equals 75 degrees. How can we say that? Because of corresponding angles. Because 75 and 1 are corresponding angles. How do we know L and M are parallel? Because of those little arrows. They tell us that they're parallel. All right, moving on to the last page. Here, let's do number 16. 3x minus 10, okay? We know that these two lines are parallel, okay? Find the measure of each labeled angle and find the value of x. So we can say if these lines continued like this, right? X plus 40 degrees equals 3x minus 10 degrees. Why? Because of corresponding angles. Okay? Because they're parallel, we can say they're corresponding angles. That whenever you have this, those are corresponding angles. All right? And that's what we have here. If this line continued up, right, you have corresponding angles. Now, let's go ahead and solve it. It doesn't tell you need to find the reasoning. I was just doing that to help you understand. Right? Minus 40. Well, let's do it this way. Let's go minus x plus 10. Minus x plus 10. 50 equals 2x over 2 over 2. X equals 25. Right? So you would have 325 minus 10 equals 75 minus 10 equals 65. They are equal, so 65 degrees. Okay, they both equal 65 degrees. Now you could check it here. 25 plus 40, 65. Boom, they are equal. Okay, so there you have it. Moving. We don't have time to jump into the practice problems for 3.2. Okay, for the practice problems for 3.2, which would be the proving that lines are parallel. Okay, so really quickly, if this angle is congruent to this angle, these are corresponding angles. So you could say R is parallel to T. R is parallel to T. You can't say anything about LS. Sorry, not R. KR is parallel to MT. Okay? You could say KR is parallel to MT. And the reasoning would be because this and this are corresponding angles. Okay, and that's what you're doing on section 3.2, is proving that lines are parallel. Sorry, not corresponding angles. The converse of corresponding angles. Converse of corresponding angles. Okay? Don't know why I can't get out of here. Okay? Again, here, same thing in terms of the reasoning. The converse of, you'd be using the converses to prove that these lines are parallel, right? 1 is congruent to 3. 1 is congruent to 3. That would be able to say A is parallel to B because of the converse of corresponding angles. Okay? If you had 2 congruent to, here's 2 to 10. Let's see if we get a 9 and 12. 9 congruent to 12, those are vertical angles. Not really anything you can say about that. Okay? 1 congruent to 8. All right? That's alternate exterior angles. So you would say that A is parallel to B because of the converse of alternate exterior angles theorem. Okay? We're going to continue this tomorrow. Make sure you practice and then do your quizzes assignment. I will have the pages uploaded to you shortly. Okay? So by the time you finish your next period's class, you'll have the teacher pages with the answers so you can practice before your quizzes assignment. The quizzes assignment will be due by the start of class tomorrow. Have a wonderful day. I will see you guys tomorrow.
Bye, Mr. Scribner.
Alright.
Actually, hey, really quick before you go, you guys, I'm going to make a notice on the Google Classroom. We're not going to have a Zoom meeting tomorrow. Okay? There will be a video recording. You can watch the video recording, and you'll be practicing more of 3.1 and 3.2. But there will not be a Zoom meeting tomorrow for geometry. Our next Zoom meeting will be Wednesday. Okay?
Okay, bye-bye.
See you Wednesday. All right, Amy, we got to go.